This video will discuss 9-7, linear and nonlinear functions. So we're going to start by taking a look at some graphs and deciding if they are linear or nonlinear. And so the idea is this, if it is a linear function, it will create a straight line of a graph. If it is a nonlinear function, it will create something that is other than a straight line. And so, for example, you'll notice this line obviously has a curve in it, right? And so this is going to be nonlinear. This graph is a straight line. In fact, has a positive slope because you notice as it moves from left to right, it's going up. So this is going to be a linear function. And then this graph, which almost makes the shape of an L, but obviously has a curve right here, okay, is nonlinear. So you're just looking at the graph to decide if it's linear or nonlinear. Okay, so that'd be one way to identify linear and nonlinear functions. Another way would be looking at the equation. So if you're looking at the equation, remember that a linear function is one that can be written in the form of a line. And if you remember the form of a line, one way that we write the form of a line is y equals mx plus b. So the question is, can we move this first equation around to make it look like that? And if you subtract 3x from both sides, I end up with y equals negative 3x plus 7. And this would be y equals mx plus b. So here would be the equation of a line. So this one is definitely linear. Okay, now this one you'll notice the exponent, which means that I'm not going to be able to get it to be y equals mx plus b. There could be an x squared, but that's not the equation of a line. So this one is going to be nonlinear. Okay, so anytime you see an exponent in there, it's going to be near impossible to get this thing to look like a line. I mean, there have to be some other crazy things going on the other side in order for it to happen. All right, and then finally, a third way. So we've talked about looking at a graph. We've talked about looking at an equation. Third way would be looking at a table. So you'll notice, if you remember slope, in order to get a line, you would have to have a rate of change, a constant slope. And if you remember, slope is the change in y over the change in x. So you'll notice that the change in y here, this is going up by 1 each time, whereas the change in x is going up by 2 each time. So if you think about it, the slope of this line is going to be the change in y, which is positive 1, it's going up by 1, over the change in x, which is positive 2, it's going up by 2. Since the slope of the line is 1/2, this would be a line. Right? It actually has a constant rate of change. Now if you look over here, let's start with y. The change in y is going up 3, up 5, and up 7, whereas the change in x is going up by, the change in x is going up by 1. So if I think about the change in x is going to be 1, however, my change in y is not constant, 3, 5, 7. I mean, I could tell you, judging off the pattern, what this next number is going to be, but it's not a constant rate of change. The difference between each of these numbers is not the same, so this one is nonlinear, right? This is not going to create a line. All right, so that's all we got for you on linear and nonlinear functions. Thanks very much for watching the video. Don't forget to do the problems on the bottom of the page, and I'll see you in class.